Hi, this is your chance to connect with the leaders who are shaping India's logistic future. Metalogic brings you the third edition of Conference on Modern Logistics for Metals and Minerals on 18th of December at La Meridian, New Delhi. At Modern Logistic, you will meet the CEOs, VPs, presidents, and entrepreneurs building powerful connections and collaborations. Learn directly from the industry experts in factory logistics, tunnels, bridges, IT, and AI. And that's not all. The landmark event will go live on YouTube at Metalogic channel. But here's the catch. We have very limited seats, only 200 seats are there. So please don't wait. Connect with us to get your seats reserved and be a part of this great gathering of like-minded individuals. Thank you.
Non-stop. Non-stop.
Hi, this is your chance to connect with the leaders who are shaping India's logistic future. Metalogic brings you the third edition of Conference on Modern Logistics for Metals and Minerals on 18th of December at La Meridian, New Delhi. At Modern Logistic, you will meet the CEOs, VPs, presidents, and entrepreneurs building powerful connections and collaborations. Learn directly from the industry experts in factory logistics, tunnels, bridges, IT, and AI. And that's not all. The landmark event will go live on YouTube at Metalogic channel. But here's the catch. We have very limited seats, only 200 seats are there. So please don't wait. Connect with us to get your seats reserved and be a part of this great gathering of like-minded individuals. Thank you. Afternoon, everyone. A very warm welcome to all of you joining us for the 58th Metalogic webinar on smart steel making, driving efficiencies and competitiveness with AI powered production planning. I am Monica Bachan Duvuri, founder and CEO of Metalogic Projects Management Services, and I'll be your host for today's session. Before we begin, let me cover a few quick housekeeping points. This webinar is being broadcasted live on Metalogic official YouTube channel. So just in case if you're feeling any difficulty in joining on the Zoom, you can also watch the program on youtube.com/metalogicpms. We'll be running polls during the session. Please participate actively as your input makes the decisions richer. If you have questions for the speakers, type them into the Q&A box. We will take them during the Q&A session towards the end. And lastly, please stay tuned and attentive. We have some very insightful discussions and live presentations lined up. At Metalogic, we always believed that the future of the steel industry lies in knowledge, collaboration, and digital transformation. Through our webinar series, we bring together thought leaders and innovators who are shaping the future of steelmaking, making it smarter, cleaner, and more competitive. In today's session, we turn our focus to AI powered production planning, a transformative approach that is redefining how steel plants operate, plan, and optimize resources. We are delighted to have with us the team of Smart Steel Technology, a Berlin-based company and a leading provider of advanced production planning software for the steel industry. SST's expertise span the entire planning process from strategic supply chain management to short-term scheduling, ensuring maximum productivity and seamless integration of business operations. Founded by AI experts, mathematicians, and steel professionals, SST combines mathematical optimization, machine learning, and deep industry knowledge to help steelmakers operate more efficiently and sustainably. Over the past decade, SST technologies have helped producers around the world to improve real-time scheduling, enhance supply chain coordination, and achieve high-quality on-time delivery, all while minimizing cost and improving energy efficiency. This webinar is especially timely and relevant because the next phase of competitiveness in steelmaking will come not just from capacity or cost control, but from intelligent, data-driven decision making. Today's discussion will help us understand how exactly AI can be applied in practical, measurable ways, right from the blast furnace to the finishing lines. We are privileged to have our esteemed panel of experts from Smart Steel Technologies and ArcelorMittal, Germany with us today. We are delighted to have our three distinguished experts with us today. Dr. Fall Florian Henrich, founder and CEO of Smart Steel Technologies, is a mathematician and entrepreneur with deep expertise in AI-driven steelmaking. Dr. Holger Braun, project coordinator, CO2 at ArcelorMittal, leads decarbonization, brings vast experience in metallurgy and R&D. Dr. Vladimir, team lead scheduling at Smart Steel Technologies, applies advanced mathematics and optimize to enhance steel production efficiently. Let's begin with our first speaker, Dr. Henrich. And Mr. Henrich, before we start, I would like to raise a poll question to our audience, and then I would request you to begin the PPT. So audience, here is a part one of the poll in front of you. So the question number one is, do you use scenario-based midterm planning? Your options are in yes or no. The second question of phase one is, what are your most prominent short-term scheduling challenges? So you have few options like frequent changes in production orders and priorities, limited real-time visibility of plant operations, coordination between production, maintenance, and logistics, data integration across different systems like ERP, MES, etc., inefficient utilization of equipment or manpower. And we have the last question. Do you use automatic allocation of slabs and coils? The options are in yes or no. So while the audience is responding to the poll questions, I will request Mr. Henrich to start with your presentation. Welcoming you.
Thank you very much. So before I go into the challenges of midterm planning and short-term scheduling, I would like to point out that I'm very thankful to our cooperation partners in the steel industry. These include ArcelorMittal, a leading steelmaker with whom we are cooperating since a long time. And this also includes ThyssenKrupp Steel, another leading steelmaker with whom we are cooperating also in the range of production planning and scheduling. And we are very thankful for our cooperation partners in the industry. When we talk about production planning and scheduling, these challenges associated to those themes can be described or can be categorized into so-called midterm production planning challenges, where we aim to create a good midterm plan for the next couple of weeks or even months for our production, and short-term scheduling challenges, where we aim to come up with optimal casting, rolling, galvanizing, and other types of programs. And for the steel sector, I think it's a crucial point to use adequate specialized software and models, since generic planning solutions often do not meet the complex demands of steel production. And therefore, our approach that we would like to explain in this webinar is how to use AI and mathematical optimization to come up with solutions to these challenges. So what are the typical midterm planning challenges? Here we can look at this example of a supply chain. In this case, we see different logistics challenges in this scenario. In this scenario, we assume that we concentrate on the main mill, caster, slab yard, and hot mill, which are depicted in this red rectangle. But we also have to consider raw material supply. We have to consider all manufacturing processes, even if we outsource some of our cold rolling activities to certain mills depicted on the bottom of the slide. We do have to take into account material transport, like moving coils from our main mill to some cold roller. And we have to try to come up with realistic scenarios, for instance, about scrap supply, slab supply, and also about sales. So the key is here, in this case, we have a very complex network of production, and to come up with a realistic midterm plan for the next couple of weeks, we must use a scenario-based approach where we can input into a model certain assumptions of ours about supply and sales, for instance, and then have a good mathematical model compute the feasibility and the effectiveness and efficiency of a certain scenario. So then let's come to another challenge. This time it's this time we focus, so to say, on this red rectangle, which was depicted on the previous slide. And in this case, if we look at this part of the production chain in detail, we have the electric steelmaking here, the casters, the beam furnaces, and the rolling mills. And here we have to take the challenge to balance different castings, like billet castings and slab castings, scrap availability, slab purchase, and the sales. When I mention scenario-based planning, this can be understood as follows. On this slide, we have depicted on the left-hand side a diagram or high-level drawing how this midterm planning works. So basically, we would use all the sales and customer orders, historic order book, and other information and use a scenario manager to create different scenarios, more positive scenarios or more challenging scenarios. And then the job of a mathematical model would be to create optimized downstream and upstream plans and also output their feasibility and associated business KPIs. This is the basic idea of scenario-based midterm planning and short-term scheduling. We'll then take advantage of these prepared course plans. And this is directly where I would jump in right now into the challenges of short-term scheduling. And these are quite diverse. For instance, on this page, we see a setup where a steelmaker runs an electric arc furnace melt shop, and then two thin slab casters, tunnel furnace, and a typical hot strip mill. And in such cases, often the grade changes, width changes, thickness changes create a challenge, and we want to have very long casting rolling sequences. At the same time, we want to minimize those changes. Here we have another scenario where we have a very complex setup with multiple slab casters, a big BOF melt shop, and multiple hot strip mills connected. In this case, the aim would be to cope with the high complexity, of course, but also to reach the top throughput in this case. So this is quite different from the previous one. Then we have another example here, just to show you the diversity of these challenges, where we have multiple beam casters, make long products, and in this case, topics like cut pattern optimization or maximization of yield and utilization of inventory are the key points. Another example showing a electric arc furnace melt shop, billet caster, then a very complex hot rolling mill, and then connected bright steel mills. And again, the challenge is slightly different here. We want to aim for just-in-time production, maximizing the yield and also utilization of inventory. And another example, an integrated steel mill with BOF shop, slab caster, hot strip mill, pickling, cold rolling, galvanizing lines. And in this case, the main aim is to optimize cost, to save energy, and improve inventory usage and avoid so-called dummy coils. So what the message I want to bring across is the challenges are very diverse and really depend on the individual case. When we talk about the inventory, we have to find a way for allocating unallocated slabs and coils. And this is one important point because it appears in every setup basically. And I want to point this out using this graphics. We see the material flow on this page. And in particular, we need, again, an advanced model to automatically consider non-standard production paths to make sure that we can match an unallocated material to a certain customer order. So for instance, the red boxes could be the standard production path of some, starting with some slab and ending with some cold rolled coil. But for our reallocation of unallocated slabs, we might need to go the yellow road. And this is an important point. This should be chosen by an advanced model and should be automated as far as possible. Then we also talk about the topic of, I mentioned the topic of dummy coils, and this terminology dummy coils means sometimes we need to insert extra coils into certain processes to bridge certain changes, transitions, and this can also be mitigated if we use advanced models for reallocation and then avoid producing coils just to bridge something. Now we would like to continue with the second part of the webinar. And this will be done together with Mr. Holger Braun. So I would...
Hi. Yeah. So let's have a poll result before we start with Dr. Holger. So I'm ending the first part of the poll question, and let's have the results, Dr. Henrich. So our first question was, do you use scenario-based midterm planning? And 80% of our audience said yes. Our second question was, what are your most prominent short-term scheduling challenges? Most of the votes have gone to 40%, frequent changes in production orders and priorities. And the second highest has gone to limited real-time visibility of plant operations. And some of them has also voted to inefficient utilization of equipment and manpower. Our third question was, do you use automatic allocation of slabs and coil? And the majority of votes have gone to no. Dr. Henrich, you'd like to comment before we start the next poll for Dr. Holger?
I think, for instance, regarding the second question, I would also agree that the changes in production orders and priorities and in general in the order book, so to say, that order book changes are really a big challenge. So I appreciate the feedback. Thank you.
Thank you so much. So, audience, I'm raising the second part of the polls before we start with the presentation of Dr. Braun. So the question is in front of you. Do you use thermal boxes in your slab yard? So the options are yes or no. So meanwhile, the audience is voting. It's over to you, Dr. Holger.
Yeah, so my name is Holger Braun. I'm the CO2 project manager at ArcelorMittal in Eisenhüttenstadt, which is in Germany. I think most of you heard already about the ArcelorMittal group. We are one of the biggest steel and mining companies in the world. We are active on all continents except Australia. We are the market leader in Europe, and we have also a huge and growing site in India, in Hazira. Here, our site in Eisenhüttenstadt, it's a rather small site. We produce approximately 2 million tons of crude steel. We are flat steel producers, so we produce coils in hot rolled, cold rolled, galvanized, also organic coated coils, and we have a quite high share on supply to automotive industry, so we can fulfill the highest demands on quality and purity and reliability, also for challenging customers. This is related to a quite complex technology routing inside ArcelorMittal. So we have a quite complex secondary metallurgy and steelmaking. We have a quite small piece order book, and so this requires a lot of challenges to production planning and metallurgical routing. So next slide, please.
So, on this slide, we depict the cooperation which we started together Mr. Braun and ArcelorMittal and SST, which can give you a background how we, so to say, what we can learn for the scheduling then. So what we see here are is the sequence of production lines, and our cooperation started already longer time ago, where SST provided surface defect classification using deep learning, AI-based deep learning. And basically the photos of the surface photos of the hot rolled pickled galvanized coils would then be mapped, their positions would be mapped back the chain upstream to the position on the strand of the caster. And this kind of data integration then enabled us to go further with the quality optimization topic. Because we were then able to put all the quality topics or surface images onto a central coordinate system, where we see a screenshot over here, and those little triangles depict defects detected in different production lines, and we map them exactly into one coordinate system. Where blue is the blue are the defects detected after galvanizing, green are those detected after pickling, and orange are those detected after hot rolling. And this kind of mapping and detection and classification was key in our effort to optimize production stability and quality. Then another ingredient, so to say, has been or still is AI-based temperature control and guidance in the melt shop, which is depicted on this page, where we take into account heat, ladle, cranes, tundish, steel grade, all kinds of inputs, and therefore have models, AI-based models for better process stability, productivity, throughput, and in the end also for saving energy, because those enable us to make the band or the tolerance, for instance, for temperature, the range much tighter, and this obviously reduces deviations and moves us very close to the optimal temperature control in the melt shop. And this really enabled these results. And Dr. Braun, maybe you would like to comment on those.
Yeah, so this you see the results on the development of sliver defects on our strips, but over the years. So as you can see, after we have a huge or significant reduction of sliver defects since the implementation of the AI-based defect detection system. What you see, it's not a straight way. So we also had look at 2022. We even had an increase for one kind of for defects, but in general, you can see a huge decrease of the surface defects that we have. So it means this tool was not the only way to reduce it, but it was an important tool, and it helped us a lot to improve the quality on our side.
Yeah, and based on these results, we then also entered together into the topic of caster and hot mill scheduling, because we all saw also big potential in that area then based on the results. And maybe Dr. Braun, you could maybe start explaining this situation.
Yeah, so I explained already before that we have a complex technology. This is mainly based on our order book. We have a very good situation in terms of coupling caster or steel plant and hot strip mill. So technically, we are very well prepared for direct or hot charging of slabs to the hot strip mill. We also implemented a hot storage for slabs last year on our site. But the problem is to synchronize the sequences in the steel plant or the caster with the sequences we have in a hot strip mill. And this is, as I said, mainly related to first to the priority of the order book we have, and also on the requirements and the quality we have on our products. So this is the reason why production planning is crucial, because every degree or every slab we can charge with increased temperature to the walking beam furnace at the hot strip mill gives a huge effect on energy consumption, on CO2 emission, and in the end on costs. And this situation became even more complex with the implementation of the hot storage boxes that we implemented, because the full advantage of this charging or hot storing of the slabs will only come if there is a proper planning on how to put slabs in which box, and in order to avoid this frequent opening of the boxes and losing energy. A second point is you see it on the left-hand side. You see we currently have BOF steelmaking on our side, blast furnace with one ladle furnace, vacuum degasser, and argon stand. But we also have plans for decarbonization of the production and shifting it into electric arc furnace. And this then makes secondary metallurgy even more complex, because metallurgically it's a completely different process, also in terms of tap-to-tap times, but also in terms of metallurgy. We will use more scrap. Scrap brings challenges in terms of sulfur, titanium, copper. So we might need a second ladle furnace, and this makes the whole process in the secondary metallurgy more complex. And the project that Mr. Henrik described before in temperature optimization becomes more complicated, more complex, and the help of let's say an AI-based planning becomes even more important than it is today. That's
yeah, and as Dr. Braun mentioned already, to get to reach the best coupling or best synchronization between casting and hot rolling, we use a modeling approach where the model generates casting and rolling programs and combination of those casting and rolling programs automatically after the user or the planning expert has entered his, so to say, requirements, parameters, and goals, and then the system generates combinations of casting and rolling programs, which exactly make sure that we put, like Mr. Braun said, the right slabs into the thermal boxes and in the right order onto the right stack, and take them out of the thermal boxes in a very useful order, effective way, and put them onto the roller table towards the walking beam furnaces. So this kind of coupling is something which is really a big challenge. And this is again where we, in our cooperation, apply those advanced models. Good. Then we are ready with our part.
So now we have a third set of presentation to be made. Before we start that, let's have a result of the question which we raised. Do you use thermal boxes in your slab yard? So I'm ending the poll and let's see the results. So audience, we asked you, do you use thermal boxes in your slab yards? The majority have answered to no. They don't use. So any comment you like to make, Mr. Henrich and Mr. Braun, before we move on to the next part?
Yeah, so for me, it's very interesting that 1/3 of the audience actually uses thermal boxes already, because we know that it's a challenge to utilize them in full, and I'm a bit surprised, but it's very interesting result for me.
Okay, so let's move on to the next part of our poll questions for Mr. Vladimir. And here are the questions on your screen, audience. The question is, how many of you make use of edger in the hot rolling mill when creating casting and rolling programs? On your screen, you will find few options like always. It's a standard part of our rolling program, often depending on product mix and width requirements, occasionally only for specific grades or dimensions, rarely due to process or equipment limitations, or never not included in our current production setup. And we have the last poll question. What are your reactive scheduling challenges? You have got a few options like managing sudden equipment breakdowns or maintenance needs, handling unplanned order changes or urgent customer request, adjusting to delay in material availability or logistics, balancing production flow after unexpected disruption, limited real-time data to support quick rescheduling. So requesting all the audience to continue to vote while I request Mr. Finkelstein to start with his presentation. Over to you.
Thank you, and thank you to Dr. Henrik and Dr. Braun for giving an overview of multiple challenges that are connected to scheduling and midterm planning. And I want to focus on just one rather seemingly simple case, just to highlight the challenges that arise and the need of the digitalization and using AI and using mathematical models, because already on this seemingly simple case, doing it half manually is very difficult. So let's go to the next slide. And it's a little bit related to connection between casting and rolling and to the thermal box. So we want to improve a little bit the slab yard, yes? And the slab yard is sometimes, maybe very often, as a bottleneck because it doesn't always look so tidy as in this picture. And let us try to understand why it doesn't look so tidy sometimes on the next slide. So in many setups, we like to cast wide to narrow. So we like to produce, the caster would cast the first slab very wide, second slab narrower, and the last slabs very narrow. And we also like to roll wide to narrow very often, which creates a problem because when we use a slab yard, the first slab, which is very wide, would go to the bottom of the stack, and the last slab, which is very narrow, would go to the top of the stack. And if we want to roll the first slab to be the widest, we would have to dig it from the bottom of the stack. And this means that this is not ideal, and we would like to solve it by planning blocks of similar slabs, where we do not have to reorder now the slabs according to their widths. So this idea of planning of blocks of similar material, it's very common and everybody likes it, but I would like to highlight why it's a little bit difficult to execute. So most, as far as I know, most of the plants have an edger. So an edger is a device in the roughing mill that allows us to reduce the width of the slab. So we can cast a slab that is a little bit wider than our final hot rolled coil. So we have a little bit of room to play in deciding how wide our slabs are going to be cast. And the idea is depicted on the diagram on the right. So with the solid line, we show the slab width, and with the not solid line is the coil width. So we would like on the strand to produce something like 10 slabs of constant slab width, but in such a way that the coil width is slowly increasing, and this difference would be resolved by the edger. So if we manage to plan our strand like the slab width in the strand as above, that would mean that when we stack these two blocks in the slab yard, we would get the slabs of the same width in each stack in the slab yard, but the coils that are planned to be of the highest width, coil width, would be on top of each stack, and then we would be able to plan them in the rolling program without reorganizing everything. Okay, so the idea is very simple, but it's actually not so easily implemented. And I would like to explain why on the example. So let us go to the next slide. So here on the right, we have a simple example of an order book with 7 orders, 2 steel grades A and B. And we have the coil width that the customer wants. And we have the weights of each order. And in the first column, you see a slab width range. So this is the range that we can cast the slabs with, such that our edger can correct for it to reach the required coil width. And you can already see here that for steel grade A and B, the edger is different. And this is also one of the challenges, that when I see an order book of 1,000 orders, I don't always remember which steel grade can be we can reduce which width by how much. Okay, so and let us just try to produce a very simple casting schedule. I would make heats of 250 tons. I would ignore all the very complicated rules of steel grade transitions. I would only like to have wide to narrow width changes. And imagine I also have 2 strands. Yeah, so I also need to distribute my slabs and my widths between strands. And let's ignore all of the complications of throughput yet. And let's also ignore the main problem that you voted, that my priorities and my all my last minute changes about the order book. Okay, so I would like to argue that already on this example, if we ignore all of the very important other KPIs, it becomes not very simple. So let's go to the next page. And on the right, we actually see so we can do 1 click or 2. So we actually see a casting program on the top. So each row represents 1 heat. And so, for example, the first heat has a steel grade A, and I would use their orders 1 and 2, and there would be on strand 1 the width would be 1500, and on strand 2 the width would be 1450, and each strand is something like half a heat. Okay, so this is a schedule that uses this order book, and so first of all, let's analyze which decisions we have to make to get here. Yeah, so 1 click, please. So first of all, we needed to decide on the width pattern and steel grade pattern. Yeah, you see that the steel grade pattern, I do 1 heat of A, then 2 heats of B, then A. And there is this width pattern that we decided to do 1500 on 1 strand, but then something different on another strand. And you would see that the same order, for example, order number 2 was used in both strands and with different width sometimes, and in different places. So, and this is due to being able to distribute the weight between the strands to pack the heats. Yeah, I cannot make 1.5 heat. I can only make either 1 heat or 2 heats. And of course, we needed to decide how to use the edger, because already we can see that orders from the order 2 sometimes was used with was cast with 1 slab width, and sometimes was cast with a different slab widths. Yeah, so there were already a lot of decisions involved, and these are actually not even all of the decisions. Let's go to the next question. Yeah. So and now comes the crucial part. Yeah, is the schedule even good? Yeah. So let's click one more time. Oh, okay. It seems like we have some basic constraints met. Yeah, the width is decreasing. We have some valid hits. It seems like we have good stacks for slab yard. Yeah, we have a lot of constant slab widths, and it's not completely visible, but we actually used all of the orders. Yeah, of course, this is usually not the case. But okay, so there is something good. Let's go to the next question. What is not so good? Yeah. So very obviously, we used two steel grade changes. We started with A, then B, then A. Could we make one steel grade change? Yeah, this would be obviously better. Maybe in some cases there is edger usage that is too big. Yes. And already I want to mention that the strand synchronization here is not correct. It's only approximate. Yeah. So when, for example, I cast the last heat and I have 1500 widths on one and 1300 widths on the second. If I split it half-half, it just doesn't work, and I start having some non-synchronization. So I actually need to work more to make it proper. Yeah, so it's not a completely final schedule. Okay, next. But the main problem is actually what is not visible. Yeah, what is not very visible is rules and violations. Yeah, we built here some table, and I claim that order number 2 was used here and there, and it's exhausted, but it's not very visible. Somebody would need to check it for another 10 minutes to actually verify even that claim. But beyond that, it's not visible if I violated the edger requirement somewhere. It's not visible if I violated further rules that we didn't even discuss. The KPIs are also not very visible. Yeah, it looks approximately that we use something. We use our stacks in the slab yard in a reasonable way, but it's not very visible. What is not visible is also what are my leftovers. Yeah, which orders actually I didn't use. Yeah, so imagine I have 1,000 orders on my order book, or sometimes 3,000. I cannot even put it in one page, yeah, and let alone to see which orders were not used or which urgent orders were not used. And the main difficulty, what is not visible, is what are the alternative solutions. Could I do better or not? Yeah, we mentioned, for example, maybe I could do less steel grade changes with these orders. Yeah, maybe I could use AABB. Maybe I needed to do a different width pattern, and then I would be able to do this. But it's absolutely not clear if such an alternative solution works out or not. Yeah, I would maybe spend another 10 minutes trying to do a different width pattern, do AA, BB, or BB, AA, and then maybe I would fail, maybe I would not. Yeah, so the biggest difficulty is that we do not see if there are alternative solutions. Even if we see something bad, we do not know if we can improve it. Okay, next page. No, yeah. So yes, what could have been done differently? And here, everything could have been done differently, but we do not have time, and we do not have time not just in this presentation. Yeah, we do not have time because we do a new casting program on a steel plant every 3 hours, every 4 hours, and I cannot now experiment for this program of 4 hits for another half an hour if I could organize it differently. Yeah, this is the main difficulty why we cannot do something differently unless we have automation. Yeah. So next, please. Yes, and of course we mentioned other KPIs. So, we did steel grade changes, but we didn't think about mix zones. We didn't think about downstream demand. We did not think about priorities that just have changed a second ago. Yes, so there are always other KPIs, of course, they're all different for different plants, or at least their weight is different. But obviously, we do not see this here. Okay, next page, please. Exactly. So I want to recap our challenges that we have, and to advocate for usage of automation and models and AI to solve this. Yeah, we had to kind of come up with this original plan. Yeah, this is how our order book looks, and we can do it with the steel grade pattern and width pattern. Yeah, so this was one very difficult place with which we had to start. Yeah, we had to decide dimensions of individual slabs. Yeah, so for every slab, we needed to decide with which widths to cast it, and actually also with which lengths. Yeah, because we also need to balance those. And we needed to make it in such a way such that our hits would work out. We needed to, here we didn't work very hard, but if we wanted to do this strength synchronization correctly, we would have to work much harder. So this topic of too many rules, yeah, so here we focused only on one problem with the edger, but I already mentioned that many times a planner in a plant with 100 or 200 steel grades has difficulty knowing what are the edger for requirements for each of these steel grades. Yeah, so maybe there are some tables, maybe some people remember. So just for one single problem, there are already rules that are not very often visible or not immediately accessible to people. There are too many decision variables. Yeah, so we mentioned how many things we had to decide, but imagine you have an order book of 3,000 orders. Every order that you don't include in this schedule is a decision. Yeah, so there are also these hidden decisions that I need to decide which orders do not go, which urgent orders I ignore. So there are too many decision variables to do it for a human efficiently. Too many invisibles, we said it's very hard to know if a different solution would be better or if it's even possible. Yeah. So, and these challenges are just too big for humans to resolve in a time that we have to build schedules. This is why we really advocate for digitalization of this. And the first topic is unified software. Yeah, you need to have a software that plans, for example, caster and rolling mill. As long as you have caster and rolling mill with a completely separate software, the caster made software does not even know about the rules of the rolling mill. Yeah, let alone it would plan things that are convenient for rolling mill or for the slab mill. Then next solution. Yes. So we already mentioned that this big data for humans is a small data for machines. Yeah. So we on purpose give you an example with 7 orders, but everybody knows that it's never 7 orders, it's a couple of thousand. Of course, for machines, it's not a problem. Also, in my order book, there were only 5 parameters, slab width and coil width and tonnage. But we all know that in every order book, probably hundreds of parameters that are relevant for production planning for different quality reasons or other reasons. Yes. So the topic of invisibility, yes, it can, and many decision variables, it can be solved by automated computations and rule proofing. Yeah. So the rule proofing, it is really not excusable that sometimes we still prove our schedules by checking the numbers. And many of the computations, like some of the dimensions of individual slabs, this really can be automated without too much difficulty. So next topic. Next. Yes. Okay. We mentioned the topic of visibility and visualization of rules and KPIs. Yes. So some experienced planners can look at the schedule and say, this is good, I can do better, but always true. Yes. For many obvious decisions, there should be automated rule-based decision making. Yes, so in this example, for example, some of the dimensions of individual slabs can really be automated by rule-based decision making. And next topic, but the most interesting personally for me. So we do mathematical optimization solvers. Yes. So for all of this, too many decision variables, and to making complex decision, what is the best pattern of the schedule? What is the best steel grades and width pattern of the schedule that would simultaneously optimize multiple KPIs that I don't even see, but I can still write them down. This can only be done using mathematical models. So we use something that calls mixed integer programming when the decisions that we need to make, they are not continuous but integer. And this completes the digitalization solution for this kind of scheduling problems that we have. Okay, so thank you.
Thank you. And I would like to add as an afterthought or in connection with what Vladimir Finkelstein just explained, that the more tightly we couple these processes, for instance, in the melt shop casting and in the hot rolling mill hot rolling, using the etcher, using the thermal boxes, what we discussed before, the more important becomes our ability to react quickly to deviations in production. And this aspect is depicted on this page. So let's assume we have created combined casting and rolling schedules where we have these slabs and these coils, but then one or more slabs suddenly do not come appropriate, maybe some quality topic or something. So suddenly we are missing a bunch of slabs, and we have to adjust our rolling program because some of our slabs already entered the reheating furnace of the hot rolling mill, or even we started even rolling some of the slabs. Yeah? So in this case, we have to be able to react very quickly and in an automated way. Yeah? Quickly because we continue to produce slabs and want to continue to roll, and automation is required because usually this reprogramming does not only involve a small change to the rolling program, but a whole bulk change or set of changes. And this is why we also would like to highlight the importance of reactive scheduling. Okay, so if we summarize all of this, what we heard in these examples, we can maybe take home the idea of a ping pong game between two processes or scheduling two processes. These can be casting and rolling, but also applies to downstream. And what we need to do here is, or what the models need to achieve, we need to balance or synchronize both processes, yeah, where you can imagine the model plays ping pong between the requirements of rolling and casting and rolling and casting. And the idea is it can play this ping pong very quickly in this analogy. And this enables automated models, mathematical models, to solve this in a very good way. Okay, that has been our presentation, and I hand over to Monica again.
Thank you so much, Dr. Vladimir and Dr. Falk. So our last part of the questions which we raised during the poll questions, here are the results. So audience, the question which were asked to you was, how many of you make use of the edger in the hot rolling mill when creating casting and rolling programs? So the majority, we have received 31 and 28% vote on always. It's standard part of our rolling program. and 28% people have responded to never, not included in our current production setup. Then our next question was, what are your reactive scheduling challenges? When we asked, so again, 32%, which is the highest percentage in this poll, people have responded to managing sudden equipment breakdowns or maintenance needs. And the second highest has gone to balancing production flow after unexpected disruption. I would like to request for comments, and also, since we have 5 minutes to conclude the program, if you have any questions, audience, you can post your questions in the Q&A box. Yeah. So your comments, please, Dr. Perk, on this result.
Thank you very much. So yes, we would also agree or support the results that sudden changes in production are a severe topic and really require reactive reprogramming of casting, rolling, and other programs. And as we mentioned in the presentation, usually a single modification that does not surface, but it triggers like a chain reaction, multiple changes, and this really, in that case, automation really is the key.
We have started to receive questions. We have a question. What is the reduction in percentage ages in sudden changes after implementation?
Vladimir, maybe you would be.
So maybe I would like to rephrase a little bit the question, yes? So after we implement reactive rescheduling, obviously we cannot reduce the number of maintenance breakdown, sudden maintenances and breakdowns. And there are two ways to mitigate such changes, such problems. So one way to mitigate is to make the schedules more robust, yes? So namely, we can make the schedules in such a way such that if a slab is not coming, the rolling programs would not be not rollable anymore. So not every slab that is missing due to some quality control issues would cause a standstill in the rolling mill. Yes. So, and this again needs to, this is always a trade-off. Yes. So we want to have more conservative schedules. This would mean that maybe it would be a trade-off with other KPIs. But I think the other topic, so again, we are not reducing the sudden changes. Yeah, we cannot reduce the number of breakdowns through the scheduling.
Hi,
what
this
we
is
can
your
do
chance to connect with the
is
leaders who are
allow
shaping
more room
India's
for reaction.
logistics.
Yes, so for example, if a sudden change is required, in some cases we are not. If you are not able to make a sudden change, you have to stop the mill. But we allow to make sudden changes. Yes, we provide an ability to very quickly change the schedule and make it work. Yes, so we and then sudden changes. The sudden change is actually a positive thing. It prevents us from stopping the program. Yes, so hopefully that answers the question.
Yeah. There's another question from Mr. Subodh. Is this system operating in any of integrated steel plant in India right now?
I can answer this question. Not yet. Yeah, it is it is in production and operating in multiple integrated steel plants in Europe and also in thin slab casting rolling plants in Europe and the US, but not yet in India. Yeah.
The next question is from Mr. Naushad Ansari. Have you used hot charging for producing HRC for grades suitable for automotive exposed? What were the results?
Yes, we use hot charging and direct charging for creating steel for automotive exposed applications on a day-to-day basis. And there is no problem with doing so if we have the right models and automation in place to react if some deviation occurs. It is absolutely possible.
Okay. So we have next question from Mohammed Arshad. He want to ask, do you have an enterprise integration product for mines integrated steel plant marketing?
We do offer software systems which are comprehensive production planning and scheduling systems, and which are integrated using direct communication through messaging with the surrounding IT landscape like MES, level 4 SAP, also to level 2 systems. So we provide fully integrated comprehensive systems.
And we have the last question from Mr. Subodh. Can your system be retrofitted in existing slab caster commissioned in the last 10 years?
Yes, our system can indeed be integrated in such a situation. We have done integrations in a diverse range of brownfield and greenfield projects.
So I think we have answered to all the questions which our audience have asked, and it's time to conclude the session. So audience, thank you to our speakers, Dr. Henrich, Dr. Brown, and Dr. Finkelstein, for sharing such insightful perspective. And thank you to our audience for your active participation. If you enjoyed today's session, do subscribe to Metalogic YouTube channel and follow our LinkedIn page for updates on upcoming events and webinars. This program was live on our YouTube. So if you want to see the recording, if you have missed it by any chance during the beginning of the program, you can watch the entire recording on Metalogic PMS YouTube channel. This was our 58th Metalogic webinar, and we look forward to seeing you again at the next time. Till then, stay informed, stay innovative, and let's continue working together towards a smarter, more sustainable steel industry. Thank you and have a great day ahead. Thank you so much, everyone.
Thank you.
Thank you.
Thank you so much. Hi, this is your chance to connect with the leaders who are shaping India's logistic future. Metalogic brings you the third edition of Conference on Modern Logistics for Metals and Minerals on 18th of December at La Meridian, New Delhi. At Modern Logistics, you will meet the CEOs, VPs, presidents, and entrepreneurs, building powerful connections and collaborations. Learn directly from the industry experts in factory logistics, tunnels, bridges, IT, and AI. And that's not all. The landmark event will go live on YouTube at Metalogic channel. But here's the catch. We have very limited seats. Only 200 seats are there. So please don't wait. Connect with us to get your seats reserved and be a part of this great gathering of like-minded individuals. Thank you.